All right, good morning, everyone. We're going to start the seminar. My name is Kevin Kelly. I'm the director of the Customer Energy Integration team here at National Grid. I want to welcome and thank you for making the trek out here to our Hopedale office this morning. It's always nice to be able to talk after a Game 7 win.
Can you hear anything yet?
So let me see. Can folks on the Okay, how about now? So anyone on the WebEx, if you're having trouble hearing or anything like that, you can send a reminder via the chat. It says I'm picking up audio right now. If anything changes, don't hesitate to use the chat feature. Thank you. Okay. So my first remark actually was going to apologize for some of the folks on the phone who had registered to join us today in person, but we received sort of an oversubscription of interest, more than we anticipated. So we had to redirect some of the folks to the webinar this morning. So I wanted to thank them for their understanding and cooperation. We assumed some of that higher than average interest in today's program was a result of an ongoing transmission cluster study that we have going in Central and Western Mass. But we really weren't going to delve deep into that topic this morning, right? The intent of this morning's program is more broad in nature. It's to really walk through the interconnection process, talk about some of the issues that impact that process. But again, we're planning on talking in more detail about the transmission cluster study. Later in May, we'll host another meeting as we did in Worcester last November and get folks in the DG community that are more directly impacted by that study together later in May. So today, the thought is to talk more about the interconnection process as it relates to simple, expedited, standard applications. We'll get into some detail about the distribution impact studies and what goes on in that process. We will talk about the transmission study process and what's involved there. Talk about the congestion that we're starting to see as a result of an uptick in volumes of applications, both in the quantity and in the size of the applications as well. So we weren't planning on talking about any specific project today. We do have representatives from my group in the room, and we'll be here throughout the meeting and after the meeting. If folks are interested in talking about a specific project, I would encourage you to reach them after the meeting to talk about a specific project. But today, again, more broad view of the interconnection process as a whole. So with that, I want to turn it over to Harley Doviak, who's been with us since last October. Give us a quick safety moment.
So just to start off the safety moment, I wanted to let everyone know where the bathrooms and fire exits are. So we do have fire exits down this hallway as well as on the other side of this wall to the right and then down the hallway to the left. And additionally, the bathrooms are down the hallway to the left back towards where you came in the door. If you take a left at that door you came in, your bathrooms will be on your left. So the safety moment, we all know that spring brings a lot of rain. An important thing that you should keep in mind with all this rain coming is that your windshield wipers are a really important part of safety while you're driving. So if your windshield wipers are streaky, making any sort of weird noise, make sure you replace them so that you can see as best as possible while you're driving.
Thanks, Holly. Next slide. So before we get into it, I just want to offer up this graph that talks about some of that activity that I mentioned, the high volumes that we received starting late 2017 throughout calendar year 18 in response to the SMART program. You can see this chart goes back to 2015. And you can see the dramatic jump that started to occur
again, both in quantities of applications and size. That blue bar is projects over 5 megawatts. The numbers at the top represent the megawatts received in a particular month. So it was definitely a shift in the force that we started to see late 2017. And that is bringing saturation to the system. Again, we're going to talk later in the program about how that's impacting the process. But this is what has driven that saturation. 2016, our average standard application was about just over a megawatt. 2018, just over 3 megawatts, right? So different looking application that we were starting to see in late 17 into 2018. Those applications where in the past they were purely solar, now they're solar paired with storage. So adding complexity to the network. Next slide. And the presentation, by the way, will be sent electronically to folks after the meeting. So you'll have this information. Folks on the phone, if you have questions throughout, I encourage you to use the Google form link that was provided. And again, before I kick it off, just want to repeat sort of our mantra at National Grid, what we're trying to do with this interconnection process, and that is interconnect these systems without adversely affecting the safety, reliability, or the power quality. That's of utmost importance to us. We're trying to do it as quick and as cheap as we can for you, but we can't lose sight of doing it without adversely affecting safety, reliability, and the power quality. So with that, I'm going to turn it over to Margaret Campbell, who's going to talk about the simplified process.
So hello, I'm Margaret Campbell. I'm the supervisor for the simplified application team. So for the next couple of minutes, I'm going to take you through our simplified process. So this first slide is really what defines the application as simple. We're looking at if it's single phase, it's 15 kW or less, and if it's three phase, 25 kW or less. And it has to be the UL 1741 SA inverters. So that's really simplified, and as you'll see in the next couple of slides, it's a shorter process than the standard one. 4 basic steps to a simplified application: submitting your application through our portal, and then once we receive that application and the documentation with it, we review the documentation. So long as everything's there, it's approved. There's the conditional approval email sent. Once the system is constructed, completion documents, we review completion documents, and then you get your authority to interconnect. So it is, again, simple process. So this is our simplified review path. And as I walk through this timeline, I did kind of want to point out some of the points in our process where we commonly see issues to kind of help you get applications through as smoothly as possible. So initially, when you're starting your application, we do recommend, if you're going with MassSmart, to go to the Clear Result portal first to apply for that MassSmart incentive. They give you that confirmation number, which can actually be entered into our portal to make sure everything is linked together. We know it from the beginning, and this helps the process run smoother towards the end. But just a recommendation, not required. And also, when you're filling out the portal, we often find problems just with names and addresses not exactly matching within our system, husband, wife. Maybe the address isn't quite the same as on the bill account. So going through our portal, if you have a customer's bill already, take that with you when you're filling out our portal. If they match 100%, it just helps to go through smoother. Your application is not going to get on hold and sent back for a simple thing. And also, in our portal, a lot of the forms we do offer electronically or upload. If you're filling them out in the portal electronically, it does help guide you through those forms, so you maybe just can't skip a box or have another mistake. Human error just helps you prevent those errors so we don't have to put it on hold. And with the application fee, we do offer the payment through the portal, which is, again, quicker. So if you're trying to get your application approved, get through quick, the online portal payment will help. Once that application is submitted, everything's there, signatures are complete, you will get a confirmation email, which is that first acknowledgement receipt of application 3 days. Essentially, our portal is going to say, okay, everything's here, it's going for a review, you get that email. Very helpful if you're using the e-signature with the customer, so you know they've signed it once you get that email. Then it goes into application review, which is the next one for 10 days. that starts, we do just an infrastructure review to verify it can stay simple. And so long as all the documentation there is correct, kind of those points we touched on earlier, you're going to get that conditional approval email. And from there, you can see because it's simple, we get to skip a bunch of steps and go to the completion document. Before getting there, it is a good idea to wait to construct the system until after you receive that conditional approval email. Just in case anything comes up in the infrastructure review, it's good to know that before you construct the system. So once you submit, oh, sorry, I have my notes. With Mass Smart, there is also the service upgrade form for adding that new meter socket, tracking the municipal inspection. We do recommend you submit that service upgrade form before the rest of your completion document, because that way you can get that work request number back, get it to your inspector when he's out there, prevent those multiple calls back and forth, just helps the process run smoother if you get that back to us. And if you fill that form out electronically also, there's some options on the back end that, again, can help you get that work request turned back around to you quicker. And also, having that form into us and the inspection called in before you submit your completion documents just helps it run smoother, reduces the back and forth of having to put on holds, wait for the inspection. So once the completion documents are in, we do our review, and assuming everything there is complete and accurate, I'm going to knock over someone's glasses here. You will get there's 2 emails you get at that point. You're going to get, sorry. So assuming the completion document is all there, we're going to go ahead and order the meters. And then once the meters are set, you'll get 2 emails. You're going to get authority to interconnect when the net meter is set, and the generation meter set email. And that generation meter set email is the one you're going to want to go back to Clear Result with to get the final SOQ for the Mass Smart incentive. And that takes us to the end of the timeline for Simple. Thank you. I turn it over to Jen now for expedited.
Morning, folks. Jen Shalafo. I'm the queen of the problem children, otherwise known as the expedited project. Expedited projects are essentially anything over 15 kW on a single phase line or over 25 kW on a 3-phase line, or essentially anything that doesn't fit into the box of simplified or standard. So the majority of projects that fall into the expedited category are under 1 megawatt. If they don't require an impact study, they might fall into the expedited track. Or anything that would otherwise look like it should be simple, that might require additional engineering and or system modification. The interconnection process steps, we start with a pre-application if over 500 kW. The application review, screening process, or the engineering review will occur simultaneously. The screening review will yield in your portal case a screening review form, which will indicate to you what the screening results have determined, whether or not there's a supplemental review required, whether or not your project may have to go for some reason to a full impact study, or whether or not there might be a simple transformer upgrade or other simple system modification that may require your project, to then move further in the interconnection process. At that point, it'll get assigned to someone like myself. I handle Bay State North and West predominantly. We have other job owners that manage other territories, but at that point, you and I will meet. We will discuss next steps. You will have to make a decision on your supplemental review, make your necessary payments, and we'll move the process through further. From that point, supplemental review or study will ensue. We'll get the results. Ultimately, an ISA will be delivered, and construction will begin post-payment. The timeline is as follows. The acknowledgement of the receipt of application, application review, and screening take roughly 35 days 30 to 38 days all encompassing. A supplemental review takes 20 business days. That said, that's 20 business days for the company's responsibility to the process. That can be elongated if there are updates to documentation, changes to the project system size, inverters, or what have you, based on the communication between you and your job owner and the overall screening inquiry from the engineering staff. We do send an ISA after 10 days of the supplemental review or study being delivered. And total max for ISA delivery is approximately 45 to 65 days. Construction schedule can be varied depending on the complexity of the system modifications required, and witness test, obviously, as appropriate. That's it.
All right, so hi everyone, my name is Sarah Burns. I'm currently working in the CEI team with standard projects. So I'll be talking about those projects. So the criteria for projects to be in standard generally are projects that require distribution system impact studies. Generally, they're larger than 500 kilowatts, but it's also project specific. So complex standard projects are DG projects that require system modifications, and now we're seeing more and more of that happening just with the influx of additional distributed generation projects that are applying. So another criteria for standard projects is inverters that are non-listed or generators other than PV. So this could be an application that's a hydro facility or CHP, anaerobic digestion. So all those types of things could be qualified as standard projects. And by process of elimination, all projects that do not qualify for the simplified or expedited process. So there are a few steps to the standard process. We have pre-application. And so during this time, you will be notified as to whether your project will be responsible for having a generator notification form or a PP5-1 or a proposed plan application, so a PPA. And we'll go through a little bit of this more throughout the presentation as we get to Carlos's section. So we also have the application. And so for application, that usually takes around 10 business days. We'll go into that a little bit further later. So we have the engineering review, which consists of screening and study. And then we also have conditional approval, which is where the customer decides whether they would like to move forward with the ISA. And then we have National Grid construction, which includes both the design and the construction portion of the project. We also have witness tests, for which the preparation can be done during the construction phase, but the actual test itself is done after the construction is completed. And then after that, we give 4 weeks for the authorization to interconnect, or ATI, and so that's 4 weeks after the construction is completed. So this is just a better view of the standard review path. So you can see once we've received your application, we do give you a notification, as with the other projects. And so to review the application, it takes us about 10 business days to complete. We also take 20 days for the initial review process. And then for the impact study itself, it generally takes from 55 to 60 business days. This is dependent on the project. So if the project has a substation modification that it requires, we generally add 5 business days to the study. And it can also be by mutual agreement depending on the cost of the study or the scope of the study. And so some projects also require detailed studies, and so these can take anywhere from 30 to 60 days in addition to the general impact study. So after that's completed, we will send out an ISA. This takes about 15 days for us to create, and then after that, the project can decide whether it would like to move forward. And so generally the total maximum number of days that it takes for this to be completed, for the ISA to be created, is 135 to 160 days. And then for a complex project that requires substation modifications, we'll have 200 days for that. And then the construction schedule is varied. It really depends on the size of the project, the location of the project. We'll talk a little bit more about that later as well. And then we have a witness test, which I mentioned earlier, but that's done after the construction is complete. So the impact study will determine the level of impact on the company's electric power standards and the required system modifications. So it will also determine the system modifications required, the cost, and the risk of islanding. So during this time, you'll also know whether your project will cost over $1 million. And so for applications that are greater than or equal to 1 megawatt but less than 5 megawatts, we have the ISO New England generator notification process, which requires the PP5-1 to be filled out. And then we also have a proposed plan application for projects that are over 5 megawatts or an aggregate over 5 megawatts. And so again, we will get into this a little bit later in the presentation. So this obviously adds time to the interconnection process. We'll have additional studies that may need to be completed. And for the projects that are larger, the distribution impact study will be placed on hold until ISO New England approval or determination is known. And so this will be likely during the study process that it will be placed on hold. So the interconnection service agreement will be provided after the study is completed or an early ISA if a detailed study is required. Again, if substation modifications are required, the company has 60 business days to complete the study or by mutual agreement if the cost is over $1 million. And so you can make a few changes during the process. So during the design process, you can change the size of the project. You can add energy storage, change a generator, change in inverters. But again, the method by which you can do that is really dependent on the type of project you have and where you are in the process. Sometimes it requires a restudy, but really it's something that you should talk to your project manager about if you have any questions or would like to change anything about the project. So again, this is a very broad, high-level overview of the interconnection process. Everything is based on the interconnection tariff rules. So we abide by that, and we expect you to read it if you're planning on applying. And so we also suggest that in order to get the most out of your project's process, we recommend that you apply early. So that way you can reserve your spot in the queue, and you can always make changes along the way if you talk to your project manager. So also to reiterate, the larger applications take longer to study. We'll go through that a little bit more later. And we do use business days to count the time that we take this, that we use to complete the study. So just keep that in mind when we give you the number of days. Also, we have the link to the tariff as well at the end of the slides. We'll post them online. So if you have any other questions, you can go there.
So let me introduce Mike Picaro. Mike's going to talk about the next section, distribution studies.
Questions on the process that we want to get answered?
Yeah, because we are ahead of schedule, I believe. So we can take some questions now. We are holding a half hour at the end of the meeting to take additional questions. But if there are any questions now specific to the simple, expedited, standard process, we can take those.
The slide you mentioned that there's going to be efforts to generate generation meters that email coming out. Is that the same for the expedited standard project?
Can you repeat the question, Kevin?
Yeah, do we want to use the microphone for?
there is a separate smart meter for generation, then you'll get the email. If you have a standalone system, there's only one meter, you will not get that.
Just good for the smart program is a lot to put in that generation meter that email, so just putting it in API again.
Well, your meter set date.
Yeah, there is behind me this.
Excuse me, can the folks that are answering the questions come up to the, where the microphone is so the folks on the phone can hear? You reiterate the question.
Yep, okay. So the question was about, for the Mass Smart incentive, after both meters are set, Clear Results needs the generation meter set. Do you get both emails? And what do you give to Clear Result was basically the question. So when both meters are set, you usually get the authority to interconnect emails first, and then shortly thereafter you get a generation, it's titled generation meter set. And that's the one that Clear Result needs in order to process the incentive. And you should, oh, go ahead.
Those emails already started going out, the meter set emails. I just haven't seen one yet.
Yeah, if it's behind the meter for 2 meters, with both meters.
This should be for like the smart program.
Are you talking about the final SOQ or the generation meter set email from us?
Generation meter set email.
Yes, they are going out. And again, maybe after the presentation, if there's a job, maybe one of us can note it and follow up on it afterwards if you haven't gotten it and you have a meter. Okay, thank you.
Hi, question about the standard process in regards to the ISO notification for projects greater than 1 but less than 5. So you highlighted in the pre-application that you would notify customers that there's the need for the ISO notification. At what point in this sequence of steps does that notification happen and ISO confirm whether or not a study is required?
So, Will Carnes, CEI. So the question was about just, and we'll touch on it a little bit later on. We actually have someone from transmission planning who's going to talk a little bit more about this. So where we traditionally did it was sort of post-impact study, right? We complete the impact study, we do it during a detailed study. What we have found through the saturation, through conversations with the ISO, that we need to pull that earlier in the process. Yep. You hear me now? You hear me now?
Yes.
Okay. So, so what we've done is we've pulled it up much sooner in the process. It's going to be being done during the impact study. So what Sarah had mentioned was that there is a potential for any study to go on hold pending a decision by the ISO on whether they're going to need more analysis done, further study done, depending on what else is happening. We're pulling that up much earlier in the process, right? We don't, depending on when we can finalize locations, points of interconnection, those type of things. Those are things we need to have to submit those generated notification forms to the ISO. Once we have that information, we're going to provide that as early on the process. There is a process the ISO moves through, right, that takes 4 to 6 weeks. So depending on when that information is available, depending on when it's submitted in, we may have to put the project on hold if we don't have a determination from the ISO, or if the determination from the ISO comes back saying that we do need further analysis or study to be done. So it will happen during impact study. It will happen as early in impact study as we possibly can do it, right? But there is information that we would need as part of that back and forth process to be able to fill out that GNF to send off to the ISO.
Got it. And then just, you guys may touch on this later on transmission planning and stuff, but it'd be helpful to understand what are the inputs to ISO that they need in order to conduct a 4 to 6 week evaluation.
Yep, and I think we can cover that. So the question for the phone was, what are the inputs that we would need to be able to fill out those forms and get those submittals into the ISO? So we'll cover that.
Thank you.
We did also have a few questions online too.
Specific to process? Okay.
So one of the questions that came in online was in regard to the ESBs. They were wondering if there was an ESB that covers all required information in a design prior to full impact study. And if there is, what would that be?
Jeannie, I assume the answer is yes, right?
So ESB 756 is the
electric service bulletin that covers distributed generation interconnections. So that one. Sure. Sure. I'm Jeannie Amber. I work in grid modernization solutions doing distributed generation standards. So I help write electric service bulletin 756 and other internal national grid standards. So ESP 756 is the place where you would refer to for all of National Grid's interconnection requirements. There are several appendices to that. There's ESP 756 main, which talks about all generation interconnection, and then appendices. Appendix C is for Massachusetts. That's where you can refer for state jurisdictional projects. Refer to Appendix A for FERC jurisdictional projects, like anything that's covered, basically anything that's not state jurisdictional is covered in ESP 756A. I will note that there are a lot of places where in 756A we refer to the state jurisdictional appendices because a lot of the requirements are the same. If you look in ESP 756, it will also refer to the rest of the ESP 750 series, which is National Grid's interconnection requirements for customers in general.
Okay, all that can be found on the website?
Yes.
National Grid website. Thanks, Jeannie. What else you got, Harley?
We do have one question about the active demand response storage program. So the customer is wondering, for behind-the-meter customers interested in participating in the new active demand response storage program, if they're not a net metering customer, can they still discharge at full capacity beyond behind-the-meter load, even if they receive no credit for the exported energy?
Yeah. You have a shot at it?
Yeah, Tim Rowan with our regulatory team, well, with the DP for 17 years here at the company. So the active demand response program, obviously anything that wants to be exported to the system needs to go through an interconnection review, right? So at the end of the day, as long as you have an ISA that details how you want to operate and you operate it under that condition, then you're okay. So, but you can't simply start exporting energy without going through a review. You can't connect batteries in parallel to our system without an interconnection review. And that's something that we're trying to get that message out to people. So because it does export, it does send generation out to the system. So.
Anything else?
In one of the slides, it said to talk to your project manager about changing the system or adding storage. Is there ever a conversation where you would talk to a customer before or after going through the impact study and proposing that the customer should actually add energy storage and sort of recommending it and it helping the impact study? Or is it always, does it always have to be from the customer to propose that storage?
Yeah, so just to answer that question, no, we wouldn't, right? We're not designing your system for you, so it's up to you. Questions we would answer during the study process is if, you were able to lower your system size to get in under some major modification, we do give that feedback and give that opportunity to make that change. But no, we don't design your system for you, and we would not ask you to do something like that.
Yeah, and just in terms of like helping the total system modifications, so you would not give any direction like it would help or not, or you would have to require design and then study it.
Yeah, right, and again, it does come back that we don't want any liability when it comes to your system, or you don't want us pointing back to us at some point saying you told us to do this and right it didn't work or it didn't help or it doesn't, So it really is up to you to design your system. Again, the feedback we would give you is if you could avoid a certain modification or a larger modification, we would provide that feedback during the study process, give you a chance to make a decision if it makes sense for your project. Because again, there's a lot of aspects of your projects that we don't have visibility of, right? And we wouldn't present that option to you.
We are going to be covering the study process just after that period. So I'll be moving there during that section of the presentation.
Do you mind passing that back a row?
Yeah.
Yeah, I think I would have added to that, that is definitely current state, right? Mentioned earlier on, there's been a kind of shift in the force. And down the line, maybe there'd be an opportunity for the utility to identify something like that. We're not at that point right now, but, you know, talk to us a couple of years down the road, maybe a couple of months down the road. I don't know, right? But it's, we recognize the system is changing. Long term, Jeannie talked about grid modernization, right? It's becoming less about interconnecting projects and more about integrating projects, right? So that element that you suggest could be in the future.
I just want to give a reminder for people answering questions, just if you could please use the microphone or at least stand closer to here. We're just having a little bit of issues with the audio right now, with people hearing it. So thank you.
Yeah, there's another question back of you.
So I just want to make a comment on what you just said, Kevin. So thank you for that, because I have seen a different ISA from a different utility, which was suggesting storage to help with voltage flicker, right? So this could be an option, like reconductoring versus storage. Just putting that out there, the possibility. But my question was really, do you have timelines on the ISO study process like you did for your standard and expedited? I mean, not that they're driven by CAP, but just sort of predictive, like approximate timelines?
Yeah, so I think Carlos is going to cover that. So the question is, are there standard timelines on ISO study processes and things like that? And we will cover some of that in our transmission slides. All right, so that's just one after. Any other questions? All right. So we'll again introduce Mike Vaccaro.
Yeah, so the rest of the program, Mike's going to talk distribution impact studies, Carlos, transmission studies, Mike back to talk about the congested area, and then Tara Resner, project manager for the SMART program. She'll close it out with a review and an update on the SMART program, and then we can take some questions.
Great. Thanks, Kevin. So my name is Mike Vaccaro. So I work in the distribution planning group at National Grid. We're good? Okay. So specifically, I cover the area of western Massachusetts, so pretty much Worcester westward, but I got counterparts that manage the different geographic areas of Massachusetts. And our group has the engineers that are performing the system impact studies and all the standard projects. So that's our role. So when we go through a system impact study, I wanted to put out here what the purpose is and what the major components are, what we're really doing when we go through those studies. I know a lot of you have seen these before, had them performed for your own projects, but just to kind of reiterate and highlight what the aspects of it are. So what we're looking for is any system impacts and the severity of those impacts on our grid, trying to ensure a safe, reliable interconnection for your site and for all the other customers that we have online right now. We would identify any upgrades that might be needed for any issues that we find. So in your report, you're going to get a clear definition of what we analyzed, what we found as a result of that, and what the resulting system modification costs would be, to be able to give you an informed decision on whether or not it's economically viable to move forward with your project, and looking at what the overall, not difficulty, but just impact and system perspective is for the area, so you know which areas are good, which are bad, which are more difficult, and sort of some of the challenges that we're up against overall as the grid keeps expanding with all the DG. Big components that we have, which I'll go into in a couple slides further down, are the load flow analysis and the protective device analysis. That's the two main categories I would put in as far as what our analyses are. So like load flow is more of a steady state analysis, looking at thermal conditions, voltage, fluctuations, things like that that could be impacted by the DG. And then protective device analysis is getting into the fault current realm, short circuit, and coordination type aspects there. So next couple slides go through the different kind of administrative bodies that go over what has to be in the studies and how we govern them. So the first one, like Jeannie had mentioned, is the ESB series. So that's our electric service bulletin. So again, 756, ESB 756, specifically Appendix C, will tell you everything you need to know from the company perspective of what we require for interconnection and what we're analyzing and what our different standards are and requirements for when you want to come online in our system. The other main components to look at and be aware of are ESB 750, which has a general kind of interconnection standard for anybody looking to connect, whether you're a load customer or a DG customer. And then 751 through 8, I just list them here as supplements because they go through different things like, you know, specifics of meter sets and things like that. So it gets into a lot of the details of everything you need. If you're going to read one document, though, definitely read 756, Appendix C. Everywhere that it's applicable, it will refer back to the other ESB series, so you get a good network of which one to go to, because, I mean, this is like 1,000 pages worth of reading. No one's going to get through all of it, but 756C will at least get you on the right track of what to design and what to include in your system, your design. So the second one down here is IEEE 1547, so that's something outside of National Grid, so it's an external body. It's a standard for interconnection of DG, and this is used to inform what the UL 1741 testing standards are. So it's an important document to read. It was recently updated back last year, 2018, mid last year. So there have been updates to it, some pretty significant updates that you want to make sure you get through. But like this is where the UL 1741 SA standard comes from, I believe. So there's a couple things that generate from it. So being familiar with it is definitely important. But again, as far as requirements for National Grid interconnection, 756. Please make sure you read that. The tariff, which has been referenced multiple times here. So that's dictating pretty much all of the process that we have, right? So all the timelines and all of the different charts that you saw up there with kind of like the pink shading on one column, that all comes straight out of the tariff. So what we have to comply with as far as how we conduct the studies and when we make deliveries out to you folks and when we expect, you know, things back, timelines for all of that is dictated by the tariff itself. And it sort of ends up dictating how we are able to produce the studies in the end and when we're able to issue those with the ISA and things like that. So it's another very important document to get through and read. Note here, you know, study timelines are dictated by the tariff. So in terms of the impact study, we have two major milestone requirements that we look for. So we have a 20 business day review, which it calls for, which we would get as far as we can in the analysis in 20 business days, and we'd come back to you with major system modifications that are known at that time. So for instance, 3V0 or substation upgrades, such as replacing a substation transformer or any significant line reconductoring that we might have to do that you wouldn't otherwise be aware of. Those are the types of things we tell you up front so that you'll know early and be able to make a decision on, you know, this project already, we know it's going to be too expensive, might not make sense to move forward, or, you know, it looks like it's still viable, yet we're comfortable with what's happening. We can move forward at that time. Also, too, if there are any options or things that we're considering, you know, sometimes from our perspective, two different options are, you know, 6 to us, 1/2 dozen the other. One might take more time, be less costly. The other one might take less time, be more costly. So there might be some opportunity for, you know, seeing how you'd like to move forward. But for the most part, we're just trying to get you the major system modifications at that time. The second timeline is the 55 business day where we have to deliver the final report out to you. In the past, a lot of you have seen that those reports come out in the executive summary. It'll have a list of customer document modifications that have to be achieved before we can go through the ISA, kind of cleaning up documents or things that might be incorrect, or we need to just kind of clean up on the plans. Those are actually now being sent out prior to the 55 business day, with the intent there of making everything a little bit more streamlined going forward, right? So we would have the study done and complete at around day 50 or so, 52, and we would send it out to you with what the customer side document revisions are, and have those cleaned up before we issue the final report, which then leads into issuing the ISA. That way, you don't end up in a situation where you go to ISA, move into construction, and we're still trying to figure out some things on your plans, trying to keep everything a little more streamlined. So it's sort of there to help our process and to help you guys have everything move smoother. So this is just showing a couple different aspects of the different systems we have. We have two main system types. One's radio and one's network. The network is a very limited area. Right now in Massachusetts, I believe it's only Worcester, parts of Brockton, and Lynn. Network systems are, we're talking area networks or spot networks. Either one is a case where that part of our system is served by two active lines at the same time. That's probably the most basic way to describe that. Everywhere else in our system, we have redundancy built in where we can tie circuits in and backfeed it from different locations, but it's not actively fed by multiple sources at once. The network systems are a lot more complicated for interconnection. So if you're looking to interconnect in a network area, definitely, consider your location wisely and what, the economics of it. And I think we can be available to kind of give you some advice if there are questions ahead of that. But just know they are more complicated, and the link there will bring you to a spot on our website that'll show you the maps of where all the network locations are, so you can see it up front and know exactly what you're getting into for where you want to connect. The second type of system is radial, which is a lot more common. So that's just, a line that would go straight out from the substation and radially feed a particular area. And again, like at the end of this line over here, there would probably be a tie point that goes to a different substation, but it's not closed until we need it if there was a problem upstream on this sub. So next couple of slides are just a few examples of the minimum of what you can expect for interconnecting. So this is showing an independent power producer. So that term, for anyone who's not aware, is basically like a large solar field, anything that doesn't have any load associated with it. So it's just generation, just DG production. So what you can expect is, the green line on the left would be our existing feeder, and we would connect from there, and you'd have to have a new gang-operated load break, a recloser, and a meter. And then from the secondary side of the meter onward would be going out to the customer site. We do require that there's a customer-owned switch on their side for the purpose of isolating our meter and our equipment on our side if we need to take your site offline and make sure that there's no backflow before we start working on our feeder. So that's the IPP. This next one here is we call it behind the meter. And again, for those that don't know that term too well, it's anything like a commercial or industrial complex that has load associated with it, and you're just adding the generation into that facility. So at your metering point, there would be a load element and there would be the DG element. So some slightly different requirements as you go through those types of setups. But this is basically showing you still have the same major components. You're still going to have a utility disconnecting means. There'll still be a recloser or breaker in between the DG and our system. So the requirements and the intent is still more or less the same, but the analysis is just a little bit different. So, and this here is illustrating what a very good one line would be coming from a developer. So what we look for right off the bat is to clearly identify all the major components that we require from our ESP. So looking for the point of common coupling where you propose to interconnect. So seeing where the national grid side is versus the customer side. Looking for that disconnect on the customer side so we can isolate the system. Redundant relaying where it's required. It's not required everywhere, but for certain sites it is. So having that on the customer side, we look for that as well, and looking for settings, which aren't shown here, but we would want to see the settings so we know what you're setting your devices at. And then down, going down, you have the interconnecting transformer in pink there, and then the green over here would be a means of effective grounding. So it doesn't always have to be a zigzag transformer as is shown. There's a lot of different options, but those are kind of outlined more in the ESP. And again, if anyone has particular project questions on an individual project, we can talk through those afterwards if any of this doesn't make sense. So for energy storage, so like we were talking about before, we would look to for energy storage and how it would be integrated into your design. There are a lot of different ways, more than I could have imagined now that I see all the different design proposals that come in of how storage could be incorporated and what the nuances of the control scheme for it would be and how it would be used. So we sort of looked for everyone here to propose the design that will work for the incentive program that you are looking to achieve. So our design, our analysis here is not going to ensure compliance with your incentive mechanism. Whatever program you're looking to get into, we expect that your design is going to be able to fall into that category. So like, we're just going to look at what you propose. So just because we look at a particular design here, analyze it, give you the results, tell you what the system modifications are, we're not guaranteeing admission to SMART or admission to any other particular program. So I just want to make sure that's clear because it can get a little confusing because it seems like, proposing the design and, the utilities looking at it, it seems to be a utility incentive. Sometimes it can get muddled, but we're just looking at the technical analysis of what's needed to keep our system safe and reliable. So, and a couple items listed here for the data requirements. So I believe everybody who submits a storage application now is receiving a list of all the information that we need to have in order to analyze that properly. So this is just an example of some of the major points that we have on there, but it's a fairly detailed list. So when you get those, submitting it as early as you can is great. I'm sure we could get the list out publicly available so that you could know right off the bat to submit all that information up front. And again, the best way to do it, the most efficient way, is if we know the project's going to include storage right off the bat. So if you have a PV site and then it goes through a certain amount of study and then we end up adding storage after the fact, that's a little more difficult to incorporate and kind of backtrack some of the analysis than if we know up front. So if you do know off the bat it's going to be there, please include it. So like I mentioned up front, the couple different analysis buckets that we have, load flow, which is the steady state analysis, and our protected device analysis. So with load flow, we're looking at, we look at both the maximum and minimum loading conditions, assuming full output from the DG. And we evaluate the thermal capacity on the line. So we're looking at thermal rating of the feeders, limiting elements on the feeders, as well as the substation. So looking at the ratings of the transformers and even backfeed up through the transmission system, which will be talked about in a couple slides from now. Dynamic and steady state, so we're looking at flicker, so like rapid voltage fluctuation, and steady state fluctuation for how it can steady state cause the voltage to rise on the feeder. Protected device, so we're looking at the available fault current, and we look at the coordination with all our other devices on the line. And as part of that too, there's effective grounding, which it's a means of ensuring voltage stability on the feeder in the case of a fault, and it's also a means of ensuring that the fault current is appropriate so that everything will trip on our line as we expect it to. So that it's pretty dynamic. And arc flash as well. We have a company kind of a program and mandate where we go through and we're checking the arc flash in all our feeders. So as more DG comes online, it has an impact on that directly. So we're checking that as well for safety of our workers and public. So. And some of the results from these. So if we see a thermal rating, it can require asset replacement. So if it's the transformer or conductors, whatever it may be, we got to replace those items with the next size up, as best we can. Sometimes the feeders are maxed out and they're already at our standard maximum conductor size. So we can't accommodate any more DG on that feeder. So we look at adding a new feeder or potentially reconfiguring an area to be able to accommodate more DG there. So we are trying to figure out the best case solutions. And we are always looking to leverage our existing assets the best we can without going straight to the, well, let's just throw a new feeder or a new substation in. We don't want to do that because it is more cumbersome for everyone. So we'd rather use what we have out there and make minimal system improvements or system modifications because of the DG, but sometimes with the penetration now it's tough. If we exceed the voltage limit, sometimes reconductoring or line regulators can be used to mitigate that. And fault current, with the protective devices, sometimes it's as simple as a setting change. Sometimes we have to add devices on the system to be able to ensure the coordination. So, and here are just a couple examples of what we see from the generation on our system. So the one on the right shows one particular site over the course of a day with cloud cover passing over the PV. So I put that there to illustrate the fluctuation from one site. So add this up over the course of, several sites over one feeder, tens of sites over a particular sub, and it just has a cumulative effect on the system, which is part of what we're analyzing. And the one on the left is showing how the DG on our feeders has shifted the peak a bit. So, excuse me, it reduces the peak and it shifts it to a different time of day. So it does cause for a different, kind of planning approach and analysis. So it is reducing overall load, but that isn't always necessarily just a great thing. It's good. It does reduce load. It does reduce some of the requirements for the system, but it does introduce certain other planning challenges that we just have to keep up and accommodate. So we're trying to incorporate all of this into our long-term plans and the short-term plan, if you call it that, analysis of the DG system when we do the impact study. So this here is to kind of highlight the effect that we're now seeing. So we've had a lot of DG trying to come online, specifically in the West, where it is having now an effect on the transmission system. So what we saw first was there was a high amount of DG, so trying to figure out how we accommodate that in a very small geographic area, which is where everyone wanted to interconnect, require new substations, rebuild substations, And in some cases, we're looking at even different distribution voltage classes to be able to physically get out to the sites where everybody wants to connect, and to also higher voltage and higher capacity, we could potentially accommodate more. But that means those are the distribution side solutions. So like from my group, we are looking at the Mass Electric MECO distribution solutions for what would have to happen in those areas. There is a dividing line between distribution and transmission. So when we get to the transmission level impacts, Carlos is going to talk through those in a few minutes, but it's the total amount that's trying to connect on the distribution side that is now trickling up and having a very real effect on the transmission side. So those are two different analyses that have to happen. So everything I've talked about so far is strictly from the substation downstream. And then Carlos, again, he's going to talk more about the transmission upstream. So it's getting, the amount of penetration we have now with the volume there is, it's having a different kind of effect, and it's like a whole new world that we're trying to get into right now. So a couple other things that come up typically in the ESB sections that they relate to. So we have 3V0, which a lot of you have heard about. So this is it's a protective device related condition where when you have a fault on the transmission line, the DG can potentially still energize the transformer and cause a high voltage on the high side, even though our transmission upstream device would have opened to stop feeding the fault. So you'd have no fault current, but you got high voltage is what ends up happening. So the way we mitigate that is we install voltage sensors on the high side of the transformer at the substation, and we have a relay element that will trip for that high voltage condition should it occur. So this ends up being an issue on higher penetrated substations. So it's a DG to load type ratio where we end up seeing whether or not the DG that's out there could actually support the substation in the event that you lose the transmission source. So for risk of islanding, so maybe a year or two ago, there was a slight revision to this. So I don't know if people remember the way it used to be, but this is the way it is now. So we have the islanding condition is one where on any line section of our system where the DG can support and continue to provide power to the load that's there, to all the customers on that section in the absence of the utility source. So an example is our substation breaker opens, and if all the DG were to continue serving everybody on that feeder, we don't want that. That's not the way it's supposed to work, and it's required that all DER resources trip offline within 2 seconds. So many times the anti-islanding algorithms in the inverters will capture this, and we can ensure that everything will trip offline. Sometimes we end up in a situation where that's not the case, and we can't confirm that that's going to happen, mostly due to DG load ratios. And DTT may be required in some instances, but many cases now we're going with the approach of so long as faults can be detected from the customer site, that we're covering ourselves for a fault condition. So in that case, a lot of times now we're able to avoid the need for DTT. And again, this is really specific to inverter-based systems. So if you have like a rotating machine or something like that, the analysis is a little different because electrically those look different. But for inverter-based ones, if they're UL certified, in many cases we can avoid DTT. Instead of that, for at least the independent power producers, maybe not so much the behind-the-meter customers, requiring a recloser at the head of the site at the PCC. So you may have had a site that doesn't require a recloser because of its size, but because of islanding and islanding concerns, we might require one for that. And in cases in the past, we have required remote terminal units for monitoring control of the site. But with the recloser there now, again, in many cases, we can avoid it. So it is still a case-by-case thing, but this is putting it out there that some of the standards in our approach has changed a bit. So, yeah. All right, so protective device requirements. So up till recently, well, I guess not till recently, but like in the past, we have required the redundant relaying to be on the customer side. So we have kind of transitioned over to the approach of allowing those redundant elements to be within our PCC recloser. So the primary elements are the ones that are within the inverter. The secondary ones, the redundant ones, were previously required to be in a utility grade relay that the customer owned. We are now putting that into our PCC recloser where we're able to. So what that means for everybody here is that you don't always need a redundant relay, so you don't have to put in a relay-based protection for your project. What you do still need to have is overcurrent protection for your site. So we're moving that functionality to our recloser, but our recloser is in no way, shape, or form meant to protect your site. So we're doing this with the explicit intent that we put it here, we're going to be good from our side, we're protecting our equipment, our assets, everything upstream is good. On your site, you're still going to need protection. So if you feel you need any of those elements that we've moved, which would be the over and under voltage and the over and under frequency, by all means, you're able to put those in there, and we'll do the best we can to coordinate with those, or even your overcurrent elements. But just be aware that we do still have the ability to change our settings whenever we need to, based on system conditions. So we'll do the best we can to coordinate, but it's not always going to be the case. But you definitely need the overcurrent protection. So you might be able to use fuses now, whereas in the past you used the relay. So it's a design consideration. It could save some costs. And it will definitely save time on the witness test, because whereas before we had to go through, check your settings, evaluate them, get all the tabletop review done, and then actually see it in the field and witness it, that can more or less go away. From your perspective, we would incorporate that into the commissioning of our own recloser. So that was it for distribution. Do we want to do questions now? Okay.
Thank you, Mike. Just a quick question on, I didn't catch the last part of the risk of islanding, where the PCC's reclosers are required in most cases and RTU is or is not required in the previous slide?
Yeah, so where we have the PCC recloser, we would not require a remote terminal unit because we have remote sensing and control of that recloser itself. So we would not need sensing and control of your generator. So, but what that means too is that we have our sensing, we have our monitoring control of the device at the point of common coupling. So that's why it makes the most sense for independent power producers, because if we need to turn the site off, whether you turn it off at the PCC recloser or at a specific generator breaker, it's kind of the same from our perspective, and it's the same from your perspective. If you have a behind the meter scenario and we do this at the point of common coupling, we're going to take the load down as well as the generation. So that's why it's a little like case specific.
And in the next slide, when you say that you need overcurrent protection, would that require a recloser anyway?
Not in all cases, so that's where it would kind of be up to you. So if you feel that you could protect your site with fuses, and we were able to move our redundant relay elements into the PCC recloser, then that's fine with us. So what we would do for a witness test there is just check to see the fuse size that you have on site complies with what you had in your design, just for a reasonable check of what the design was lining up with what's in the field. But the real redundant functionality would be in our recloser.
Thank you.
Yeah.
I've got one. Hi, Edwin Fo from Bloom Energy. Question regarding effective grounding. You highlighted in your impact study slides that you would conduct a review and evaluation of effective grounding.
Mm-hmm.
During the screening, the screeners do highlight that effective grounding might be required, and that could occur at project levels 250 kW and greater, right? I believe this was in the DSB. So does that then mean that any project greater than 250 would need to go into an impact study to be evaluated?
So, well, not necessarily, but yeah, I mean, it would depend on a couple different factors. So, I mean, the means of effective grounding, we would look at it based on the site size, and if it was of a concern, we would end up asking for it. So we reserve the right to ask for it between 250 and 500. Over 500, it has to happen. So that might be why you're seeing that comment of it may be required. So there are instances where the screeners do talk with my group, and then we determine whether or not it is required before it goes out. So
let's say it is required, right, for something between 250 and 500. Does the evaluation of the proposed effective grounding have to occur during the impact study?
It has to occur during an engineering review. So it might not be an impact study. It might just be a supplemental review. And that's kind of what I believe those are intended for in the tariff is like, you know, a check of one or two specific things that we need, but it doesn't require the whole 55 days. So that would be where you would see it go, supplemental review.
Got it. Thank you.
Yeah.
For
moving the relay requirement to your side of the meter, can that be in effect for projects that already have their ISA but have been built yet? Is that something that we could change the design, or is this only for new projects that get applied for after this date?
So it is something you'd be able to do if you haven't yet completed the site and have your API. We've been careful about how we put it out there, I guess, because it's not mandated. So if it's actually more difficult for you at a particular state to move it, you don't have to. If you want to, you can. That's probably the easiest way to say it. And we would just need to see the revised drawings, how you want to modify your design to accommodate that. We take a review of those drawings, and so long as that's the only thing that changed and we're still, we're just moving the functions from one to the other and nothing else is changing on the site, obviously getting rid of the relay and putting in fuses, say, would be expected, but yes, it's something you can do at any time. Thank you.
Yeah, so let me introduce Carlos Perez. Carlos is a manager in the Transmission Plan Asset Group working for New England Power, right, which is an affiliate of National Grid. Mike, manager of distribution planning, right, works for Mass Electric, governed by the tariff that we've been talking about all day, and DPU 1320. Carlos works for New England Power that manages the transmission system, which is an affected system of, the region. We're able to get him today because he does work as a National Grid affiliate, but it's, he's governed by, different set of tariffs, works closely with ISO New England, and, he can talk about how the impacts of all this additional capacity has called out a need to work closer with ISO New England, right? So the tariff itself hasn't changed, and DPU 1320 has not changed. It's just what we've seen change is the volumes that we're processing. So Carlos can speak to some of the additional requirements that ISO is asking for now that we hadn't historically seen, but given the added penetration and saturation, they're now more keen and wanting more analysis from us. So, Carlos?
Thank you, Tim, for that introduction. Again, Carlos Perez. Specifically, I cover the transmission planning aspects for Southeast Massachusetts. First of all, can everyone hear me on the back? Yeah. Okay. So I cover the portion of Southeast Massachusetts and Rhode Island. I also have a counterpart that covers the rest of Massachusetts and the rest of our service territory. So the purpose of my next 3 slides here is to convey the process established by ISO New England based on their planning procedures, and also the guidance that ISO New England has provided to us based on the recent interconnection projects that we have worked on. This slide here, this table here describes the proposed plan application requirements and for all new generation or changes. And it's based on size of the project. So just want to highlight that for this section is an excerpt from Planning Procedure 5-1, and when we look at the sizes, the way that ISO has this written is that that based on footnote 3, that for purposes of a station here, ISO says that encompasses all of the a grouping of generations and terminal equipment that are within a continuous fence, right? Also, based on footnote 4, the net station output delivered to the point of interconnection, and that matters a bit on when I'll explain that a bit when I discuss the generation sizes between greater than 1 megawatt and less than 5 megawatts. Let me start at the top. For any new generation or changes in net station output or greater than 5 megawatts, 5 megawatts or greater, ISO requires a proposed plan application for that interconnection, which also requires a full transmission planning study that should follow the guidelines of Planning Procedure 5-3, which that procedure lays out the different level of analysis, and should also follow the performance requirements and modeling requirements of Planning Procedure 5-6. So 5-6 lays out how the interconnection study should be performed by the transmission planner, and it also details the modeling requirements for stability models. Anything that requires a proposed plan application requires a stability model that needs to meet the ISO criteria. So it has to be on standard library cases that ISO accepts at the time, and it has to it has to reflect the functionality of the interconnection. Moving on to the project sizes between greater than 1 megawatt and less than 5 megawatts. ISO does not, it's at the ISO discretion. Typically, they will not require a proposed plan application. They require a generation notification form. Previous slides, you have heard this as a 55-1 form. However, if ISO determines, though, that based on the type of projects and based on how they're interconnecting to the existing feeders, that they may determine that that specific grouping of projects may require a proposed plan application. To explain that a little bit more is that, let's say that if a particular developer has multiple projects that are between 1 and 5 megawatts, but they connect into the existing feeders and there's no load in between those feeders, and we will reach out to ISO, but ISO will most likely say that those two particular projects require a proposed plan application, because from an ISO standpoint, they look at the point of interconnection, and both projects will have essentially the same point of interconnection, and ISO will treat it as greater than 5 megawatts. So in that case, they will require a proposed plan application, which will need a full transmission study. For projects that are less than 1 megawatt, equal to 1 megawatt or less than 1 megawatt, ISO does not require a transmission study and does not require any modeling requirements. So for those projects, essentially there is no ISO involvement for projects less than equal to 1 megawatt or less. This slide here, to tie it back to the previous table, details the levels of analysis based on Planning Procedure 5-3. For level 0, as already mentioned, a proposed plan application is not required. Typically, the type of project, the size of projects that fall under this are projects that are 1 megawatt or less, and there is no ISO New England involvement. For all the other projects, for instance, projects that are between 1 and 5, typically, as I mentioned in the previous slide, that requires a generation notification form. But then, depending on the transmission area and how much other distributed energy resources there is on that area, and the amount of distributed energy already in the area, ISO will predetermine the following three things. One will be that there's no supporting analysis required for that generation notification forms. The other one could be that there is some level of analysis that ISO required. It's not a full-blown, it's not a complete transmission study, but it will be some low-flow analysis to show ISO that the proposed distributed generation project operating simultaneously with other existing or planned projects in the area do not adversely impact a major interface on the transmission system. But then, if there is a lot of distributed generation in the area, and ISO already feels that it has reached the tipping point, and they have more concerns that there could be other adverse impacts from a stability perspective or other concerns, ISO will determine that we need level 3 analysis for that specific project or a set of projects in that area. For the level 3 analysis, the level 3 analysis is essentially the full-blown transmission study. That one requires testing of low flow, as Mike mentioned on his previous slide. We look at thermal analysis in there, whether there is any overloads or do we see any voltage problems on a steady state perspective. We look at short circuit. We assess the fault duty of the area to make sure that all of the transmission breakers are there within the fault duty capability. It's understandable that inverter-based generation does not have the same contribution of fault duty as conventional generation, but when you look at an aggregate in a respective area, that's something that we need to evaluate to make sure that in aggregate the fault duty is not significantly impacted, that will require additional upgrades to our existing breakers. It also requires the stability analysis. That is the stability transient analysis, which require stability models. This is one of the things that we have seen that customers have an issue with coming up with stability models. There are certain requirements that ISO wants for those stability models, and these requirements are listed in Planning Procedure 5-6. Other thing I forgot to mention is that today ISO hasn't asked us for the individual interconnections to provide PSTAT testing. However, that's another type of testing that is at the discretion of ISO, and that it will require the customer to provide the PSTAT models. But we will let you know as specific to the respective interconnection as we learn more from ISO New England. This slide here provides you the study timeframes based on the different levels of analysis. Based on past analysis and also based on the Planning Procedure 5-3, for a level 0 interconnection, well, there's no requirement to do any analysis, so there's no really any time frame for that. For notification forms, though, that depending on the area complexity and that could take between 1 and 4 months, right? Because it could be that if we are in an area that we already have a lot of other distributed resources on that area, ISO will want the study will be more, the analysis could be more complex, and we have to vet the analysis, the results of the analysis with ISO New England. So it will be an iterative process just to make sure that we vetted all the different concerns that ISO may raise. For level 3 analysis, that's the complete transmission study. That the timeline for that would be 3 months to 12 months, depending on complexities with the respective areas and the size of the interconnection. One thing I want to mention here is that, as determined by ISO New England, there could be impacts based on other FERC interconnections in the area. ISO will determine whether a FERC interconnection is relevant to the transmission study for a distributed energy resource that we're trying to perform. And what ISO has communicated on this is that if a FERC project, let's say that we are performing a transmission study for a distributed generation project, but we're in the middle of the study and we haven't secured the proposed plan application approval yet for that study. If a FERC project comes into an area and ISO determines that that's a relevant project for the distributed study, that FERC project will take priority over the study for the distributed generation. What that means is that the timeline to completing the distributed generation study will be dependent on when we get the modeling data from the FERC projects and when ISO has more certainty about the modeling data and any potential upgrades that the FERC project needs to account for. So that could impact the actual study timeline. Any questions?
So just a couple points as I'm walking around the room here for a second, right? So you mentioned the PSCAT model. So anyone who has a project that got caught up in the cluster transmission study in Central Mass, we have requested PSCAT models to those as of yet, right? So if there are questions, right, specifically to those or why we need them, maybe you could direct those to. Sorry. So, hear me now. So just we can direct maybe some of those to Carlos now, and we can always follow up with that that aspect of it later. And the other big point that I want to make sure that we get across and emphasize here, excuse me, is that traditionally, right, it's been an over 5 megawatt generator or an aggregate of a same developer, right, contiguous type property, sort of aggregate to over 5 megawatt generator that has triggered these PPAs. That's no longer the case, right? So that's why we talked earlier in the conversation about submitting the generator notification forms earlier in the process, getting the ISO involved, getting an idea of what their expectation is for the amount of analysis or study that has to happen. It's not just you and your one project now, right? There's multiple projects. Anything going on in that area could impact the need for additional transmission studies. So I just want to make sure that we emphasize that as a big part of what's going on here, and that's a big change as we continue to move forward.
You mentioned that FERC projects take priority. So is there any list of FERC projects, or how would we be able to find before we were even submitting for an application?
On the ISO New England website, on the ISO New England website, there is a public listing of the ISO queue listing, where you'll see the FERC project interconnections, as well as the non-FERC interconnections that ISO has already captured on their listing.
Carlos, in addition to that, we had a question from online about FERC projects. If you could just really quickly discuss what FERC means, and additionally, they wanted to know, is it something that will be interconnected on transmission system versus distribution system? So just kind of identify what makes a project a FERC project.
Okay. So there is a different criteria there's different factors to determine whether a project is interconnection is FERC or non-FERC. Typically, this will be the projects that participate in the forward capacity market, but I think that there could be also another. Yeah. I think that in addition, though, this will be the large generation projects that participate and that go through the ISO process that are not state jurisdictional. But there could be instances where a project on the distribution system becomes FERC, and then any subsequent project on that feeder could also be deemed FERC.
Yeah, I can address a little bit more of that. Tim Rowan again from the regulatory group. So the FERC jurisdictional projects flow through the ISO Schedule 23 or 22 based on the sizes. And those are projects that specifically, anything connects to transmission, FERC jurisdictional. As Carlos said, you can also have projects connected to local distribution if they're looking to sell to outside or third parties. But if projects are going to work through a state-sponsored program, net metering, SMART, et cetera, they do flow through the state jurisdictional process. Now, the complication is that as those projects go to interconnect through the state process, they then, in many cases, and the recent DPU order allows this, they also want to participate in a wholesale market. So the complicating factor is that now we've got a state jurisdictional project, and SMART we'll call it, but also has FERC jurisdictional aspects to it. So the challenge we now have is how do we manage those two separate queues? The state queue that we had that always essentially never impacted the transmission system because we didn't have a whole lot of generation in the system. But now it's 1,300 plus megawatts on our system in Mass alone, right? And 2,500 statewide. In fact, if you don't know it, Mass is the 7th most solar installed in the country. You know, only New Jersey in the local area has more than Massachusetts has. That's just the long and short of why we're at this level of saturation. But the fundamental problem we're challenging with now, and we're having conversations with the FERC, is do we then send projects that we know are going to be participating in the forward capacity market on day one to the ISO New England for interconnection processing or not? Now the challenge there is that the sheer volumes of those projects is so large that the ISO simply doesn't have the resources to manage that. Whereas the state utilities have geared up for the volume and can manage those projects. So we're in this sort of wait and see attitude where if we know you're going to be a state program like SMART or net metering, we're going to process you through the state jurisdictional procedures. However, at some point in time, once we know you're in a wholesale market, we then are obligated to file that interconnection agreement with the FERC. So your project now becomes FERC jurisdictional at that point. And there's other aspects to that that you need to know about. There's a lot of issues relative to that generator owners need to understand because there's certain things like Federal Power Act authorities to sell energy and all the rest that's fundamentally required for projects like that aren't required for state jurisdictional projects. So it is a gray area. It's a sheer volume problem now. And we are having separate conversations on the administrative side of the house with the ISO and the utilities to sort out how best to deal with those. But the issue that Carlos brings up, the FERC jurisdictional project, does take precedent over the state jurisdictional projects. It's a condition we're working through to understand better because lots of folks have some anxiety about that, and it's still a work in progress. This whole process is a work in process, right? To get 2,500 megawatts to request to interconnect to our system for a 500 megawatt allocation of SMART was just overwhelming for us. We've never seen that volumes. And fundamentally, between us having to then go to our transmission providers like New England Power and other affected system operators, to then bring the ISO New England up to speed on the sheer volume of these projects, it's just simply taking time to figure out how best to manage them. You know, there's hundreds of generator notification forms that still need to be approved at the ISO. They do them monthly at their reliability committee. So we're processing them as quickly as we can, and they're working with us as hard as they can to process those. But there's just a sheer volume challenge we're running into now, and it's just going to be this surge. We'll get through it. We understand what we need to do, but we all just need to be patient for this window of time while we work through the complications of the high levels of saturation we have in parts of our system. That's why, for many years, we've required a pre-application report so folks know what they're getting into, right? We got a lot of applications at the 2,500 megawatts that didn't bother doing a pre-application report, right? So they went in blind to get in line for SMART, right? And we know how it works, right? But the fundamental reason is that's why we had that. That's why it's been in place since the 2013 revision of the tariff. So we can tell you, look, you're going to need a new substation in this area. There's no place to plug you in. But, you know, a lot of people didn't even ask for those when they applied for that with the massive surges that we saw there. So that's something that's in the tariff that we're working on. And obviously, as we move forward, we're also working on other sorts of things like DG hosting capacity maps that will show you, as you click on a map, where and how much DG is in the area. We already have them in place in New York and Rhode Island. We're working on them for Mass as we speak. So it's going to take some time to pull those together because a lot of manual work to actually make those happen. But, Jerry?
Can you say something about how this would impact your proposal for group study?
The group study is pure distribution level study, so it's not a piece and part. The group study is distribution work. It doesn't, and a group study can still and will still likely be affected by the need for the affected system operator work. And whether it's New England Power as our transmission provider, that happens to be in Central Mass. You know, we have other parts of our system in Western Mass where Eversource Transmission is our transmission provider for Mass Electric customers. And the real issue now is Mass Electric needs more delivery capacity to serve its customers. And then we have to go to our transmission provider to get that additional capacity in the form of new or expanded substations.
So group studies will be treated as non-FERC?
Group studies are under the distribution tariff, so they're non-FERC, yes.
not up to ISO?
No, it's our reporting obligation as National Grid, both from to a FERC level and so it's our obligation. We're the ones who get penalized if we don't follow the proper rules of the FERC. So again, that's the subject of discussion with the ISO as we move forward. They simply don't have the resources to manage it. It's just that simple. So there's no way. But group studies, again, if they're in state jurisdictional programs, right, then they would stay state jurisdictional, even if we've got lots of them. There's other complications when you're setting up assets, energy capacity, previously reg type assets that come into play that are separate and apart from studies, but that these things are critical paths you've got to understand, and that the whole premise of setting up a model generator, that's, again, a piece of the new DP order that's out there. So, in the back?
Oh, we have one.
Oops. I'm sorry.
Hi. Are you considering issuing conditional ISAs in parallel with the transmission study?
Not until we know the results of the transmission study. Because fundamentally, the ISA won't give you the full cost of the project if we don't know if there's a transmission impact until the study is complete.
Okay.
Good question. In regards to your quota system right now, has there been any thought been given to a separate quota for 5 megabyte and larger, separated from the smaller ones? Are they all going to be put together, on a waiting list together?
Well,
right now.
they're all on the waiting list together. Sorry. So he's asking about, is a separate queue, I think, is what he's really mentioning, for 5 megawatt or greater, or for a project less than 5 megawatts. Is that close enough to it? And the answer is no. It's, our queue is set up by the day your application is considered complete, right? Now there's some conversation about that queuing as we get farther in the process, whether that's still a legitimate way to queue or not, because there's projects that simply move faster than others, that are ready earlier than others. And the whole premise is to get people online as quick as we can. So there's a lot of discussions going on, but a lot of things we don't have all the answers to. So, yeah.
To the point of projects that are in SMART and potentially also participating in ISO markets, the ISO has identified the potential need for a transmission service agreement in addition to the ISA. Where would that be identified within this process, or is that a separate process?
That's a completely separate process. If you've applied to the ISO for interconnection through Schedule 23 or 20, so Schedule 23 is 0 to 20 megawatts. Schedule 22, I think, is over 20 megawatts at the ISO level. That's right. So whatever their process is, you would follow those separately. Yeah.
This is a question for Carlos. Could you please outline the milestones in level 0 and level 3 and just talk a little bit about how much time those milestones take just to break down the 1 to 4 months and the 3 to 12 month period?
All right, so for generation notifications, right, it is all dependent on the complexity of the respective area. Because, I mean, it could be that, let's say they're bringing an area that does not have a lot of distributed generation in that area. The actual analysis will be quicker. It could be even less than 1 month. But now if we're getting into an area that has a lot more DG in that area, and all of a sudden the analysis indicates that there are some of the scenarios that are not really solving, or that we have reached the limit when we do this transfer analysis, what we do there is that we look at the injection of the project, and we transfer we then look at an area outside that respective area, and we transfer the injection. Think of it as the source and sink, right? So we transfer that much megawatt from the source into the sink, and in the process we do the contingency scenarios and look at, for each different contingency scenarios, are we seeing any problems between those two areas, right? If we're seeing problems, then we have to determine is it relevant to the specific project, and Once we do that, if ISO reviews our results and says, wait a minute, we're not in agreement that the specific contingency scenario that it's showing up as a potential issue that's not relevant to your project, go back and make sure that it's not proof to us that it's not really being caused by the respective project. So that's where the complication occurs, and that's where it could take a month. It could take longer than that, depending on the volume of distributed projects on that specific area, right?
I was just looking for some breakdown. Does the analysis itself take days, or is it a communication that takes days, or does it happen on a regular frequency?
For generation notifications,
Can you repeat the question, please?
The question is the analysis the one that takes the longest, or is it the communication between ISO? It's both, right? It's the review process by the ISO New England and the analysis, and the feedback that we get back, and how much time it takes us to redo the analysis and provide the results back to ISO New England, and the ISO New England process for review. That's for notifications forms. As far as transmission studies, the process is a little bit longer because we need more modeling requirements, right? We need to model the specific projects. We need to make sure that we have the right cases from ISO New England, the right projects in the area, and then once we have approval on the scope of the study from ISO New England, then we perform the analysis, right? The analysis is it's more involved. It's a lot more scenarios that we need to look at. It's 3 types of analysis. It's a load flow analysis, but also the stability analysis. We do faults on the different parts that are relevant to the projects, and we have to review on what the performance is of the project and all the generations in the area. So the actual analysis takes longer there, and then we have to have that analysis reviewed by ISO New England. So it's both the analysis and review process by ISO New England.
Any other questions?
All right, John Kennedy, I just want to add to what Carlos just said. Volume also adds to the timelines, right? Typically, especially with the full studies, we experience a lot of back and forth to gain the proper data, the proper models that will actually work and can be run. And all of that has to be in place before the study can actually begin. So I just wanted to make that point. We have another question back here.
Thanks, John.
Thanks. First off, thanks for putting this together, bringing everyone in the same room. This is helpful. And that, I guess that analysis you're talking about for the generation notification forms, what's that called? What's the phrasing we're using for that? Is that a transmission impact analysis, or?
What ISO has been calling for is some sort of level mimicking the transfer analysis. They refer to it as a transfer analysis, but it's not the same transfer analysis. There's more detail that ISO performs on the transmission system on, I think it's on an annual basis. This is more a more streamlined transfer analysis for the specific projects to demonstrate that there is an adverse impact based on load flow analysis.
And my question is actually a combination of Will, Carlos. So what's the process that we all have set here now? Because I think we've got projects going through this, and how we understand it now is projects, if they're a 20 business day review, if they're in this 1 to 5 megawatt range, this generation notification form is put together. I believe projects all get put on hold while this transfer analysis is being done. Once that transfer analysis goes to the ISO, it goes on to the consent agenda if they agree with it, and then it goes to reliability committee for approval, and then projects fall out and of that hold and then go back into a system impact study, correct?
Would you like
All right, it's taken several months, but I think we're starting to get it.
No, I think you explained it properly, right? They do have to go through the reliability committee. The challenge there is they can only process so many. They only meet once a month, right? And that's our issue now. And John brought up the real issue of just the huge volumes that they're now having to process. So they're working through it. I mean, they're going to get through it. It's going to take time to get through the backlog. Again, prior to the saturation levels we've seen, you know, we typically, as Will said, the generator notification points were we just did them when we got around to it. And now we realize that, nope, they have to be done as early as possible to understand completely, right? So, and that's the big change in terms of what we're doing to try to process them as quickly as we can. And we've got this surge we've got to deal with, you know, so we just need to be patient while, you know, between ourselves as a distribution company, our transmission providers in the area, and the ISO New England, there's a lot of different moving parts we just need to keep pushing forward on.
I guess all of it, what's the reason for the project on hold while they go into that once a month?
Because we have a time enforcement mechanism, and we'll be dinged if we exceed the average study timelines, and therefore, it's not the distribution company's fault that the projects are on hold, right? The tariff language has always included effective system operator language, always talked about if the ISO needs X, Y, and Z, the project will be put on hold.
Right, but there's no way to do the impact study in parallel with the patient analysis order.
Could you repeat the question?
What could happen is the transmission impact, if there is, could affect that distribution.
Yeah, he's asking if the distribution study can go on concurrently with the transmission review, if you will. And John Kennedy's answering the question, which says essentially, look, until we know what the transmission impact is, we don't know where we're going to plug you in. So therefore, we could do a distribution impact study, but if we find out where we did it to doesn't work, we have to move someplace else. You folks all know about how fun the permitting process is for your solar farms, right? Well, just think about all the fun we have with permitting new substations, right? We're getting a whole lot of additional concern from all our towns about the significant tree trimming our new three-phase lines to serve solar farms is taking. A lot of towns are getting very angry with us because we're destroying all their trees down the public way. But we have no choice because as customers, we're obligated to serve, and we need a certain amount of clearance for that construction. So there's a lot of issues with the cities and towns we're going to deal with as well that's over and above the ISO New England challenges, the effective system operator, transmission providers, that is really coming to fore in a big way. We were recently at a town meeting, Will and I, a month or so ago. The biggest complaint from the folks in the town was the trimming we were doing down the right of way, down the public way, down the streets, taking down all their pretty old trees. Believe it or not, that was what they were really concerned with. So that's going to come to fruition. You know, Mike talked briefly about the fact that the sheer volume is such that we can't triple, quadruple, quintuple circuit 13 kV feeders down public ways. Operationally, you can't maintain that. When they come down in a storm, it's a god-awful mess to pick up. So we can't do that. So now we're looking at, do we change our distribution voltage from 13 kV to some higher voltage? As Mike said, it produces additional capacity. Well, that's going to put even more pressure on those trees on the side of the road as we need to trim to maintain reliability. So the success of all of us in the room here of being the seventh most solar in the country has consequences, and we all need to work through them together. So I think that's the key message today. But
so we do have a few questions online that we're going to take, and then we're going to need to move on to the next part of the presentation. So Carlos, they were looking for kind of an overview of the PPA process in relation to the project size that requires the PPA process. And additionally, if you could speak to the models required, more specifically, a site-specific TSS/E model, if it's required for transmission study in the PPA process.
So, based on the table, right, anything that ISO determines that is 5 megawatts or greater, that requires a proposed plan application, a PPA. So anything that requires a proposed plan application requires to meet all the requirements from Planning Procedure 5-3 and 5-6, which calls for the modeling requirements. So in order to support the full transmission study, for this project, for anything that is 5 megawatts or greater, it requires the PSSC model. It requires the stability PSSC models to meet the actual requirements for ISO New England that are detailed in Planning Procedure 5-6. I think that right now, I know that ISO is not accepting user-written models anymore for this PSSC stability models. They are looking for standard library PSSC models in the current version of PSSC, which I believe is version 33.
Thank you. And then, Mike, we do have one question that came in relation to the PCC reclosers you were discussing. So the customer is wondering, is there a limit to system size that can be protected by a National Grid-owned PCC recloser? Above a certain size, will we need a customer-owned PCC recloser as well?
No. So if I'm hearing that question right, is there like an upper value where they would end up needing another recloser? Or?
A threshold limit for using a PCC recloser, presumably one recloser or?
Yeah, no, so there's no upper limit. As a matter of fact, the higher you go in site size, the more likely it is that you're going to need to have that recloser there. So it's going to become more of a requirement as you increase the size of your site. From the other end, like a lower site size, there isn't necessarily a lower limit anymore because, like I said, in certain instances, we require it there because of the site size specifically. So 1 megawatt and greater absolutely has to have it. Lower than that, it may be required in order to avoid things like DTT or other requirements to avoid risk of islanding. So.
Thank you. And from there, we're going to move on to the next section of the PowerPoint. So Mike is going to discuss the congested areas and the ongoing distribution and transmission studies.
So this section is relatively short, just one picture. But what it's showing here is it's illustrating the area of Massachusetts that's currently affected by the ongoing transmission cluster study. So a lot of you might have projects that are within this area, so we just thought it was good to get it up there on a map just to really illustrate the sheer volume and what we say about the amount of the system that's actually affected. So the different colors in here, like obviously you can't see them down into detail, but it's kind of meant to illustrate which subs are affected by it. So each different color illustrates the distribution lines that are coming out from a particular substation. And then those are all the substations in the geographic areas of really high proposed DG penetration. And the thicker red lines illustrate the transmission lines that connect all those different areas. So where it started, I know I touched on it a little bit earlier, but I guess to reiterate, where it started was that we got really high volumes of DG penetrations in very targeted areas. It prompted the need for different voltage class distribution, which means new substation transformers, rebuilding substations, retiring certain substations and replacing them with new ones, or altogether just adding new substations to the area for support of all the DG. Carries with it a lot of complication from just actually getting the substations built and physically finding the location for where to put them. And it also requires a reconfiguration of pretty much all the feeders in that area because we're not building express lines or express subs to serve DG. It's serving the area in total. So it's serving the load and the DG, so we've got to reconfigure everything. So you can see this all ends up spanning from the entire middle part of the state pretty much all the way out to like the North Adams area up in the Northwest. So it's a lot of megawatts, a lot of projects that are affected by this. But I think saying that doesn't really drive it home as much as showing you the physical locations of where it's all happening.
Mike, could you just provide some narrative of what the legend represents? It's not.
Oh, so yeah, I mean, yeah. So so the legend itself isn't exactly important. So each color is a different substation. So that's really all it's saying. So
you have black cross mark, and you have.
Oh, I'm sorry. Yeah. So like these marks here are just indicating the different service territories that we have. The colored areas are really what was kind of meant to be focused on. So
how are you determining what constitutes saturation?
When we need to replace substation transformers, rebuild substations, or add new ones. So it was a distribution-based solution that affects the transmission system. That's what kind of dictates.
For everything that's included.
Yes.
Thank you.
And the other point we just want to make is that we were requested quite often. We have some 50 substations, I think, are being impacted by this overall cluster study. We have put up on the website a list of all those substations with the towns that those substations are located in. So if you are looking, I want to say it's in two different places, right, Harley, on the website. So if you can't find it, reach out to one of the job owners. I can definitely help you find it. But there is a list that exists now. That breaks this down a little bit further so you know exactly what substations are impacted. I think there was a question, right? question.
Just wondering, how far along are we with the solutions in these specific areas? Are you able to provide like a percentage of how far are we along?
So I think Kevin mentioned earlier in the meeting that we are going to have a meeting next month in May that is going to dive a little bit deeper in. We have kicked off the transmission study, right? And I think, as was mentioned a couple of times, we need to have that transmission study completed to understand what the impacts to the distribution solution are. We are going to have more. We're trying to figure out, right, the speakers for that meeting, the timing, the location, all that stuff, but it will be next month where we'll dive a little bit more in depth into where we are with the transmission study, where we are with the distribution solutions that we've identified to this point, all right, and what we expect the timelines to be. So we don't have all that information now, but we'll provide all that next month.
So Mike, if you could speak a little bit more on who is requiring the area studies in terms of distribution versus transmission and how that's being covered by the affected system operators. Kind of explain what that term means a little bit more.
Sure. So I guess to be clear right off the bat, this is not a group study as defined by the Mass Tariff. What we ended up doing was, again, because of the volume and the amount of megawatts looking to interconnect in certain areas, it didn't make sense anymore to look and keep blinders on and look at just one substation and find that individual solution for what we could do out of that one sub and limit ourselves to that one area that we're looking at. We had, over 100 megawatts in most of these areas trying to interconnect all at once. So what we tried to do was leverage what we had there, what was available to the best of our ability, and then see how the different substations could be leveraged together to be able to get the most we can out of that area and interconnect as much as we can. So that's where, instead of just saying, we're looking at this one sub, oh, it doesn't work, let's just rebuild a new one right next to it, we looked at, okay, what's actually happening with the other substations around it, what's all the DG in the total area, where does it make the most sense to put a new substation to get the most bang for our buck? So if we did the old way of looking at just one sub, we might have built two subs instead, but now we build one that accommodates more. So it's an area analysis that ended up happening from the distribution side. And that's where we came up with our solutions of rebuilding subs, adding new transmission interconnection points, adding new transformers, adding new substations altogether. Once distribution came up with what we would like to accommodate the area, that's where we we coordinate with transmission, and that's where the transmission study is happening now, which is being required by ISO and NEP right now. So hope that answers it.
Thank you. And there was a question that came up, Mike or Carlos, I'm not sure if one of you could speak to this, but there are questions coming up about the inverter models being used on these projects in their current one lines in relation to the time delay that's being caused by these ongoing studies. How will we assess retired inverter models and changing inverters, if there's an answer for that, understanding the process is ongoing?
Probably more for transmission, like the transmission study.
So, inverter motor, can you repeat the question? I'm not sure if we actually have an answer for that one, but.
Yeah, understanding the process is ongoing, answers are still in development. Is there any information about what we'll do with inverter models being retired? So, for example, these one lines that currently exist for these projects, with the time it takes to complete these transmission and distribution studies respectively, is there any information about how we'll deal with the inverter models being retired potentially by the time that these studies are concluded?
Yes, I need more information on that question. With regards to, is the question that, is it the inverter models that are no longer acceptable for ISO New England based on current criteria, or is it that if the study takes long, that there may be other inverter models that could be retired during that span? I think that based on, because of how the study works, we are going to agree on the scope of work with ISO New England. So if anything that, based on all the current assumptions, when that scope of work for the study was determined, that's going to, ISO will respect that. I don't think that ISO will come back and say that, wait a minute, now, since you started the study, we have made some changes to our procedures, and now you need to go retroactively go back and abide by these new better requirements. Usually that doesn't happen.
Carlos, I think a good way to answer that is it's a case-by-case basis. We deal with that now if inverter companies go out of business. Inverter models, if inverter models are no longer available from the time that the customer applies, provides a one line, and then we get to the end of the process, customer's ready to build, interconnect, we already have a ISA service agreement in place that we request the customer provide updated one lines, updated information, we analyze it. If it affects, if we need to restudy it, we will. But it's case by case. We deal with that same situation right now, whether we're in a congested area or not. So that's how we handle it.
And then, Carlos, we do have one question referring back to your transmission presentation. So for the systems less than 5 megawatts, but greater than or equal to 1 megawatt, they just want you to review kind of the PPA being required for larger projects versus a PP5-1 generator notification form process.
I think we're becoming competitive, respectfully, and I just want to do a time check because maybe we should move on.
Yes, 10:58, so we do have 2 minutes until we were intending to start the next part of the presentation.
Twice already. I don't know if we just want to put the table up in the beginning of this presentation. We can refer to that one more time.
So, ISO has the discretion to indicate whether a PPA is required, even for projects between 1 and 5, or maybe not, or even a full-blown transmission study. It all depends. Again, it all depends on the area, how congested that area is, right? So ISO will make the determination when they're reviewing the notification forms, and if it reaches a point that says, the area has a lot of already DG projects in the area, it has reached the tipping point, generation notification forms is not sufficient anymore to address to analyze the potential impacts, then ISO has the discretion to ask for a full transmission study. Not sure if something that hasn't been determined by ISO New England yet is that if the project is truly 1 to 5 and it cannot be aggregated to be over 5 megawatts, will it require a proposed plan application, or will it still only require a generation notification form but a transmission study? That hasn't been determined by ISO New England yet. Something that we'll have to coordinate with ISO New England.
Okay.
All right. So I think Tara.
Yeah. So just to acknowledge that there are still questions coming in online. We don't have enough time to address all of the questions that are coming in, and we're moving on to the next portion of the presentation. Tara Reisner will be presenting about the SMART program.
Good morning, everyone. Can you hear me in the back all right? Yep. Okay. Excellent. My name is Tara Reisner. I'm the program manager for the SMART Solar program. So we're going to be switching gears a little bit. This is really a high-level overview of the program just to cap off this morning's seminar. Can I just give it back to you? So the SMART program, it's to give 1,600 megawatts of distributed solar throughout the state of Massachusetts. And that 1,600 megawatts is spread across all 3 of the distribution companies. The compensation works by a mixture of a credit on the customer's bill and an incentive payment that's paid monthly. This is a chart just to give you a basic rundown of the differences between SMART and the SREC programs, which were the previous solar incentive programs in Massachusetts. As you can see by these 2 charts on the right, the SMART program is the sad-looking chart on the top, and the SREC is the one on the bottom. So generally, the main difference in terms of incentive is that during the SREC days, you had the ability to get a lot more of an incentive, but it was variable based on how the RECs were being traded on the market, and you were only paid quarterly. Now with SMART, you get locked into a flat rate incentive at the beginning of your program with your final SOQ at the very end of the program, at the end of the application. And depending on how much you generate per month, you just have your incentive rate times how much you generated, and that's how you calculate the generation incentive. Another difference is the meter used to be just whatever meter your installer wanted to install. Now it has to be a utility-owned generation meter and net service meter. So we have one meter that's there just to collect the gross generation of how much the system has produced in the month. And then the utility service meter is, of course, the net meter to calculate your bill. So this is the current block status. You can find this, it's updated generally daily on our Clear Results website, which is masmartsolar.com. This is the National Grid numbers just for you here. This was from April 15th. For the small projects, which are generally the residential or anything below 25 kW, we're in block 2 of 8. Each block, so this program's a declining block structured program. Each block declines by 4%. So your base compensation rate will be smaller depending on which block your application gets locked into. So the higher incentive is at the beginning of the program in block 1, and of course it's lowest in block 8. So for small projects, we're in block 2 of 8 right now, so we're forecasting this could go on for a couple of years. And for the large projects, which are larger than 25 kW, we're already in block 8 of 8. So once it gets filled up, there's going to be a wait list. If project earlier on maybe drops out or gets kicked out for some reason for the application, then there may be room for a new project to join. But we're almost at the capacity for large projects. And we are not sure yet what the decision will be in terms of adding new blocks to the end. We're still waiting on the department to make that decision. This is from last week, but this is how many applications National Grid has received since the program opened at the end of November. We have received a total of 3,780 applications from all different size systems. This is obviously, Mike kind of explains what behind the meter is versus standalone. Behind the meter is if there's premise load, standalone is if there is not. So we've of course seen a lot more applications for generally the small behind the meter customers, residential customers. And in terms of standalone, we've seen more large than small standalone sites. So all of this, it really has been a busy few months. So this is just to show where all the money comes from for this incentive. So we are now the ones paying the customers, whereas for SREC programs, they were paid directly through the Department of Energy Resources. So all the money that funds these incentives comes from your bills, so thank you, everybody. The new rate is called the distributed solar charge, and that all goes into the pool of money where we're paying the incentives from. This is a little disjointed, sorry for the order of the slides here, but when you get locked into a block, it tells you what your base compensation rate is, and then you have the ability to kind of customize your incentive rate based on adders. So this is the first time we've seen the adder of battery storage. So if you decide to have a battery at your site, you get more money on your base rate. Of course, there's some other ones for like the larger sites, if it's over a landfill, if it's over a parking lot. There's different ways to kind of get more money per month. These are the two options. If you do have a standalone site, you can either be an AOBC facility, which is alternative on-bill credit. And what that means is that you, as the host who owns that site, can allocate different amounts of energy to different off-takers. So during the application process, you have to have 100% of your energy allocated to different people. But this is the type of site you would have for community shared solar. So you decide during the application process, I want to give, this much to my grandma, this much to the guy down the street, this much to whoever wants to participate in my site, and then I, as the host, can receive the incentive payment every month, and the off-takers will receive a credit on their bill. And then the other site is a qualifying facility. So if I, as the host, don't want to deal with anybody, I can just get the wholesale rate for my energy every month paid to me. So this is just a breakdown of how much we are charging for the meters. So depending on what site and design you have, you would have to pay a different charge for what type of meter you needed with your design. So this happens during the application process. You'd work with your job owner to make that payment once it's determined which type of meter that you needed. that's kind of it. I mentioned this website earlier. We're working with Clear Results as our solar program administrator. So if you want to open an application, obviously some of you have done this already, but you go to Clear Results website, you open the application. Updated FAQs and documents are always loaded onto that website, and you can also go to the main page, click National Grid on the left, and you will see that block status update every day if you want to check. So, questions?
We're having problems with a customer who already went online who's going to get paid as a QF standalone. What's the process for that? Is the smart payment and the QF payment going to be paid at the same time? Is it going to be totally separate, like you'll get paid as a QF on one check and then you'll get the balance on the smart payment on another check?
I don't know, Vishal, do you want to answer that?
So the question is, your system is online. You haven't received final SOQ yet, right? So you already received the final. Yes, I think so. We're in the transition phase right now, and until you see your final SOQ, you will continue to get your QF payment. And once you have received your final SOQ and you get the notification that you have it, we will transition you from QF to the smart incentive. And at that time, you'll get one single check for both years, to the total compensation that you're going to get from your system. Correct.
Thank you.
Yeah, we do have some questions online. So this question in relation to SMART might be more of an engineering question. It's relation to placement of meter. So the question is, can a smart meter be located on the secondary side of a customer-owned transformer for any size system? Are there any limits to this? It doesn't make sense to install a primary meter for a 100 kilowatt system, for example.
So I believe the way the smart metering is set up right now is that we do end up needing 3 meters so that we know the total of what's actually being generated, what's being used for storage, and what's going to be at the total head of the site. So those would all be on the National Grid side. So it would have to be on ahead of the point of common coupling. So having something on the customer secondary side of their transformer somewhere within their system, I don't believe is currently allowed with the arrangements we have.
Thank you. And then there are some questions about rates in relation to these programs. Could you please explain how a blended rate is calculated for a project that encompasses multiple SQA blocks? Is this prorated based on AC or DC capacity? Does each portion of the system in a given block need to be metered separately?
Yeah. So the question was about if there are more than one incentive rate on the same system. So yes, you would need different meters for each of those different rates. So for example, I have a system over my parking lot in the back, but then I also have one that's over a landfill next door, and they're under the same account. So they would both be metered, and what we would do is we would actually average them. So that's what the blended rate name comes from. So that would be your rate, and then every month you'd get that one incentive payment based on how much you generated from both sites under that new blended rate.
And then we have another question in relation to alternative on-billing credits. Would National Grid be willing to offer AOBCs to behind-the-meter smart customers, given that net metering is no longer available to them?
I don't believe so.
Could you just say that a little louder?
So the answer is you're in the one program or the other. So if you're net meter, great, well, good for you. If you're not, then if you want the other program, you got to follow all the stipulations of the other program. Again, the regulations are out there from the DOER, and the department, the DPU's approved those tariffs in place, and the rules are the rules. It's not, so National Grid doesn't have the luxury of making any exceptions to them.
Yep.
Will we ever get to see any of the metering data, like in a DAS type of situation for this smart meter that we install?
Yeah, at this point, so the question, I'm sure everyone heard because you have microphones, but in case people on the phone did not hear, the question is if our meters are capable of showing like generation, kind of like a locus meter, something like that. The answer is no. These meters do not have that capability right now, but hopefully they will someday. Yeah. So if a customer wants to monitor their site to show what they're doing on an average day, we would recommend that they install an additional meter, probably from their installer, to show that production.
Yes.
And also, I would recommend that when we file an advanced metering proposal in Massachusetts, you say, yes, we want that. Because then we would have the proper metering in place to provide all that data. But today, they're just most are just watt-hour meters. So we don't have any sort of interval capability in the meters. We just know the total that's been generated or consumed between one day to the next.
Yeah, but if it's interval meter, under the enhanced metering tariff, we can, offer the 2 pulses.
Yeah, you can get pulses.
Pay additional money to install people's cabinets. Sorry. Yeah, if it's interval meter, we do offer, under the enhanced metering tariff, we do offer additional pulses to be provided, so we can install a KYZ cabinet and you can get the data from us. But there'll be additional charges for that.
All right, sorry, off the hook.
What?
You're off the hook.
Thanks, everyone.
Thank you. All right, so I think we still have a few more minutes, Riley, right? Do we want to take a few more questions? I think that's the end of our presentations. All right, thank you to all the presenters. I think we got a few more minutes to be able to take some questions. Do we have more questions in the room? Any topic?
How many more were on the, we had a lot on transmission, right?
Yeah.
Yeah, there are a few more in relation to transmission and some in relation to billing as well. And then we do have some area study related ones. I don't know if you want to speak on the area study requirements. They're questions about the requirements that we've given to the developers. So their current question is not what
What kind of
Sean had a question, I think.
This question actually goes back to what Tim was saying and the fact that the ISO Reliability Committee meets once a month. Do you know if, due to the increased volume, that ISO is planning to do anything to increase their ability to review these applications or forms?
We're working with the ISO to get through this bottleneck right now, and so we propose different options to them. Obviously, they only have what they do and how they do it, right? At the end of the day, they've only got so many resources there. There's no way today, at least, for them to collect fees for some of this work. So they've got their process. And just to be clear, I mean, the ISO is a FERC regulated entity. They're not regulated by the Mass Department of Public Utilities. You know, and not that they're not interested in working very closely with, state issues and concerns, which they are. But I think so. There's a lot we're working on to try to accelerate some of those. And one of the options is can you have additional meetings? The problem is you need to have all the backup data and analysis to be able to have the additional meetings, and that takes a lot of additional time as well. So working on trying to streamline it, but yeah.
Yeah, and kind of going off of that, given the sheer amount of applications, what is the criteria of selection for the Reliability Committee to select those projects and review them?
So the generation notification forms, that's something that is presented to the Reliability Committee, as well as the projects that require proposed plan applications. So essentially, any project that is 1 megawatt or less, it doesn't have to go through the Reliability Committee.
I'm not sure to answer your question. What I'm asking is, once we determine that those projects are 1 megawatt, 5 megawatts, or under, need to go to that committee, because there are so many applications, how do we determine which ones go first?
And could you please reiterate that question?
Yeah, so I think the question is there a sort of a priority as we're submitting those? So we're a little bit of a backlog, as I've mentioned. Let me turn this on. So there's a little bit of a backlog, as I've mentioned. as we transition the process from what was traditionally a post-ISA process to now what's being done during study. So we have a lot of DNFs, right, that we're submitting, and we're submitting them sort of all at once, right, and the ISO is looking at them. What's happening, right, is that due to the saturation, we're triggering the need for a lot of additional analysis and additional studies, part of it. So I don't believe that they're actually prioritizing as we're submitting them, so they haven't given us a number that says if you submit 50, we're going to look at 40, and the other 10 don't make it in, right? If we submit 50, they look at 50. If we submit 75, they'll look at 75, and they'll make a determination based on what the next steps are for those. So there really is no prioritization. On our end, when it comes to prioritization, we're obviously focusing on projects that are post-ISA now, right? And we've been working through those. We're working on sort of a queuing aspect of how far along different projects are as we're prepping those. We're undertaking considerable amount of work, right, to get those GNFs filled out. We've got a number of resources working on those and working directly with Carlos, his team, and the ISO team to make sure we're getting those submitted as quickly as possible to not further delay, right, that sort of information or any sort of next steps that we need to have on the ISO. All right, I think there were questions over here.
In reference to the modeling requirements of 5 megawatts and less, what can we expect our customers to submit to the utility as far as the PSCAD modeling in reference to generic inverter models, site-specific inverter models, aggregated models, including the collection system, up to the point of common coupling, and any validation requirements for those models?
So the models for the models are required for the generators that will be modeled explicitly. Those will be projects that are 5 megawatts or greater. So for those, we would, or even the 1 to 5, if ISO New England determines that there is that we need to perform a complete study. For those, we might need just the the impedance information for the transmission planning studies. We would need the impedance information and the generator step-up transformer information, right? So, and we need the impedance information between the substation that connects to the transmission system back to the point of interconnection of the project, and the GSUs and the generator unit capability, the megawatt capability and the megawatt capability.
So I understand the above 5 megawatts in the ISO PP56, but we've had recent requests for our customers for smaller systems under 5 megawatts. And at the moment, it only appears that an inverter model was requested. But I'm kind of like looking forward, is the utility going to be requesting more detailed PSCAD models required by the customer?
I think this may be in relation to the...
Yeah, I think I can answer this question. If I understand correctly, the projects that are in cluster study right now, and Will can correct me if I'm wrong, we have asked customers to submit their PSLC models by June 1st so that we can begin the PSCAD study, which is part of the transmission study, the cluster study itself. Outside of the cluster study, if we do require a PSLC model, I guess we have another job on this, we'll definitely reach out to you if ISO do require additional analysis for this process. Yeah, I think we're getting some questions. I know, like, we got a few questions. Neil was it, right? Yeah. Okay, I think so. Jeannie is in the process of responding to that email.
So I just wanted to point out something that I received that I believe was sent to customers. This is the PSCAD model requirements for the Western MADER cluster study. There are and it goes through what the requirements are, so if you haven't seen this, definitely ask for this. But it's basically saying that it's replacing what's in ISO New England PP5-6. So you can start looking at that. I looked and compared the two. They're very similar. But when I look through it, I'm looking at it kind of from a phase 3 solar perspective, the utility-owned solar that we're kind of like studying for the benefit of Massachusetts customers. And when I looked through this, kind of with you know, my developer hat on for a moment, I said, okay, what am I going to need from the manufacturers? So I noticed that it requires external voltage controllers as part of the model, so you are being required to have a site model. Now, the other important piece is that you have to have a model that is according to what you're going to do on that site. So what we experienced is that we requested a model from a manufacturer. When that manufacturer provided the model, they provided us, in one case, the best practice, which is to take what's literally in the inverter's code and put it into this PS-CAD model. That part is best practice. The part that became a learning experience for all parties, really, was that inverters are used all over the globe, and inverters act differently based on how they're programmed. So they're programmed differently for the U.S. versus somewhere else. So this particular manufacturer needed to know that we needed to have a Rule 21 ISO New England ride-through requirements inverter set up. So they had to specifically set the inverter PS-CAD model up so that we could change those settings in order to do the PS-CAD model showing, hey, we're going to regulate voltage and frequency on this test site, only on this test site. But they needed to know that so that we would be able to configure that model for the studies that we needed to do. So that's something to consider for folks that are owning sites. That kind of is a phase 3 solar learning I'd like to share. So definitely ask for the PS-CAD model requirements for the Western MADER cluster study. In the meantime, you can always go on the ISO New England website. It's ISO New England PP5-6, Appendix C, and that's the PS-CAD model requirements. I just looked this up the other day, so I can't answer a bunch of questions on it, but I wanted to at least share that because I think it'll be helpful.
And Jeannie, is this a link we can provide as part of?
I Googled it, but yeah.
Okay.
We're just giving Will a work on it. Could you please talk a little bit about inverter derating and how you view that and what's acceptable and what you expect from one line?
Yeah, so inverter derating, so like if you have what's a standard, say 1 megawatt inverter, but you want to derate it down to, I don't know, 759, whatever it might be. Yeah, because that's what happens to work for your site. So we do allow derating of the inverters. It has to come straight from the inverter manufacturer and has to be provided with a revised nameplate. It doesn't have to be the stamped UL approved nameplate, but it has to be a labeling by the manufacturer of the derated amount for that inverter. And it has to be such that, not just anybody can walk up and get into the system. Only an inverter manufacturer representative with the special passwords can get in to change that. So it has to be as secure and static as possible. As far as documentation within the study, we would look for some kind of written confirmation from the manufacturer that it has been, securely derated down to that lower size. And then when we get to the witness test, we're going to look for that label on the unit itself.
I just have a quick question in regards to the quota system. As it is right now, as to how many new projects you can bring online on a yearly basis, and there's a cutoff, and you have to wait till next year to bring on new projects. Is there any thought been given to increasing the quota? Who sets the quota? Is it the state? Is it the federal government? Who's telling you how many new systems you can bring online?
So ultimately, there's no quota, right? The only quotas are for the programs of the Mass DOER, the SMART program. They do have a quota, right? But for under 25 kilowatt, three-phase connected three-phase lines, and under 15 kilowatt connected single-phase line, there's no cap on the net meter caps. So you can have as many of those as you like. But there is if you want additional funds beyond that meter, a smart adder that Tara talked about, there's going to be limitations to that. But that's all set by underlying legislation, which then the Mass DOER then turns into regulations and then we eventually turn into tariffs, which the DPU eventually approves, and that's what we use going forward. So if you're looking to increase any sort of the amount of solar being installed in Mass, you know, then that's, you start with the legislators, essentially, is how it works.
They're the ones that put any limitations on it?
They're the ones who look at what makes sense for customers. I mean, you know, we do have to weigh, you know, the cost of these programs to everything else, right? At the end of the day, you know, whether we like it or not, these, you know, we knew going to solar and carbon-free electricity was going to cost more, and it is, right? We're all paying about 3 cents extra per kilowatt hour if you're a Mass Electric customer. You know, if you're in Eversource territory, you're probably paying about 2 cents a kilowatt hour more because they're not at their net metering caps, and we are. So we have more on our system than Eversource, and so our customers pay more for the subsidies. So we know those costs are out there. We also know, being the 7th most solar in the country, the reason why is because we've had fairly lucrative subsidies, right? What drives installations? Either high capacity factors, which we don't have, you know, which Arizona does, or, you know, subsidies that drive the market, which is what we saw in Mass, right? So, but there has to be a balance between the two. At the end of the day, you know, customers are, I mean, I'm paying 25 cents a kilowatt hour in my house for the winter. You know, that's what it costs us all winter if you're on standard offer. And of that, 5 cents are due to clean energy programs. So it is what it is. And we all know we have to pay it, but there's a balance. And so that's where, when you get to the legislators, they understand that larger balance.
So we're going to take a break from the in-person questions for a minute to address some of the online questions. So the first online question we have is looking for some commentary on the influx of applications in the interconnection application process. Are those fluctuations in applications mostly related to the incentive programs or any other kind of trends that are going on, just in terms of are there better times if you're not trying to get into those incentive programs? Is it better to apply around them, before, after, and just a general?
Yeah, I mean, the incentive programs, when they open and close, drive volume. We saw that in the 2010-11 window when the first 400 megawatt goal was set. Remember those days that we blew through in 2013? And then the next 1,600 megawatt goal that we blew through in 2017, that was supposed to last till 2025, right? And then SMART, that are supposed to last till 2023, all our blocks are full, and it's 2019, right? So at the end of the day, that's what drives the applications, the underlying, the dollars and cents. The old days of doing hourly analysis of customer load to generation, installing solar to be coincident with load, which is how everyone used to do it pre-2010, right, is something that you really need to think about going back to maximize your solar opportunity. Because even without SMART and without net metering, the more coincident you can make your generation to your load on site is, either through load management or energy storage on site, you can, you know, reduce your essentially average retail price of electricity. And I just said I'm paying 25 cents at my house. So, you know, I don't need SMART if I can maximize most of the generation I put on my house to be coincident with my load, right? Now that gets challenging. I'm not going to suggest it's easy, but at the end of the day, that's where folks are interested in trying to move forward here. But yes, it's driven all by the state programs that are out there and the subsidies, et cetera, et cetera. So.
Yeah, I think Kevin presented a slide at the very beginning showing the trend that you can see right up until the beginning of 2017. We were pretty even. And then with the SMART, the end of SREC, right, the beginning of SMART and those types of things, we saw those huge spikes. And now, as the fully subscribed buckets, right, that we started to see a pretty big decrease in the number of applications and the size of those applications that are starting to come in here over the last couple of months. So we'll do one more question here in the room.
When you say the net metering caps are full, is net metering and virtual net metering kind of all inclusive in there?
It's the same thing. Yeah, net metering, right? So, you know, the premise of virtual net metering was, you know, a creation of the regulatory environment. It really wasn't in statute at all. It just was a regulatory order in 2009 that created virtual net metering. Okay. But it is the same cap. Yeah.
My last question is on the meter locations for the SMART program. If we have indoor metering, which was allowed previously, does the net meter that gets installed and the service that's inside all need to be moved outside, or only the smart generation meter that is new to the system need to be installed outside? And are there any exceptions or processes?
So let me just clarify something. Anytime a customer is upgrading an indoor meter, they were required to go outside, and that's been for decades. We've required that under our prior ESBs for metering. We have to remember that DG has a special tariff, has a special ESB, but there's plenty of other requirements for services that we've had for decades. And any time a customer had an indoor meter was going to go from a 60 amp to 100 or 200 amp, they were required to put the meter outside. So any service upgrade, which is what you're probably talking about, we should attempt to bring them outside. Now, there are case-by-case things we can talk about depending on the physical nature of where your meters are now. You know, we have customers with meters at the road, and the house is 300 feet back. We made a few very rare exceptions for that sort of installation. But otherwise, meters should be in the same location, and they should, if they're inside now, should be brought outside.
Even if you're upgrading one of the services that goes inside, there's a bank of 12. Do all 12 need to be moved outside?
By rights, if you're upgrading the service to the thing, they all should be moved outside. That's been practiced for decades. Electricians know that. The problem is there's a lot of new people in the solar installation field that aren't familiar with standard service upgrades. And that's really been the larger challenge. Thank you.
So we're going to move back to some of the online questions coming in. There have been several coming in about the recent changes in terms of additional requirements to the interconnection application process, in terms of additional requirements such as civil engineering details, letters of authorization from the AHJ or authority having jurisdiction, and additional requirements in regards to landowners, things of that nature.
Pretty broad.
Well, again, the first one about the AHJ, or the Wire Inspection Authority, has been the standard rule for decades too, right? Until the world of smart came along, people don't understand normal service upgrade requirements. It was always a requirement for the inspector to look at these things and approve them, and or depending if you wanted a separate service, there always was that local requirement to approve that. And that's also part of the National Electric Code. It's got nothing to do with smart. So that's the other challenge we have is the electricians who've been working in the field know the code and they understand that, but some of the new folks in the field, aren't clear about it, think it's new, and it's just going back to the basics of upgrades. But I don't know what the other...
Also, Tim, we can point to our other electric service bulletin. We refer to 756, which covers our interconnection requirements. But we also have a electric service requirement bulletin. It's ESB 750. So it's equally as important, when you're doing electrical work on any premise, that you refer to that ESB also.
So what were the other changes? Maybe you're closer to these other.
So there were several questions about it. I kind of just tried to summarize it. So the first question references civil engineering details regarding access roads and letters of authorization from the AHJ. The second question also references those letters of authorization and goes into more depth about how AHJs are hesitant to provide those letters. The third question references the letter of authorization again in reference to a second service to a facility that's explicitly allowable by NEC 230.2A5. And the third one goes on again to reference those civil engineering details regarding access roads and other engineering requirements as well as the...
Well, I can talk to the access road piece. The problem is very simple. Folks have said they're going to build something and we're going to have access. And then we get there, we don't. Right? So we've got no choice but to be more specific about it. It's always been a requirement. It's just people have abused the need for it. They cut a road in, it's all muddy. Our 10-ton line truck tries to go down it, and we're not going to drive down a muddy road with a line truck that we're going to have to pull out with a tow truck, right? You're going to have to do the proper work to make sure that roadway is, but that's access to the company equipment. That's in the ESB 750. That's what we require for Walmart to have if they want us to put the service on the back of their building. right? And those are just standard issues. And I think we just have to be more specific about them because people haven't been complying with our requests. But the other thing about the inspecting authority, I think it's all.
Yeah, I don't know that we have a lot of control over that.
No, exactly.
I think we've stated that we're not going to install second services for buildings without the okay from whether it be the fire department, whether it be some other town, and to be at that point signing off on those. So that's the expectation. I think that this has become a bigger issue recently because of the changes in the type of systems that we're starting to interconnect, right? It's not just behind load systems, right? We're seeing a lot of leased roofs, right, that are requiring, they're entirely separate from what the load or the owner of the building is, and that's necessitating trying to keep those things separately. So as we've mentioned here, old rules just being enforced more often now as part of that. And with the access road, every one of the job owners knows and understands what the requirements are for an access road. So if you don't know, you can specifically ask your job owner for that project, and they'll be able to walk you through what those expectations are. And we are working on a more official National Grid document that we can hand out or post on our website to make sure you have access to all that. So, but like I said, every job owner that you're dealing with on my team understands what those requirements are and can relay what those requirements are. We are getting a lot of pushback as we go out here, and our operations guys are going out and pre-checking these jobs, right? One of the recent ones we dealt with that the supervisor got out there and the road is just up the side of the hill, right? It's not zigzagging, right? We can't get a line truck up there. We can't get our outriggers down. We have to be able to install, right, what needs to go in, and then we have to be able to maintain our equipment going forward. Aspects of gates need to be double locked if the gate is going to be out towards the end of the property, right, that has National Grid easements and equipment on the other side of that gate. We have to make sure that we provide you a lock that we can then open that gate with. So those are the type of things, all the job owners, like I said, are very familiar with that and can walk you through and talk you through all those. And we are working on getting a document that we can post and have available and make sure everybody knows exactly what the requirements are specifically to the solar side access roads.
Other questions?
So I'm actually going, I think we're sort of past time. So there was an email that went out this morning, I think, again, to everybody, but there is a Google link that the people online have been using. We'll actually, I don't know if we got to all the questions in the room, hopefully we got the most, if not all of them. We're going to leave that open here till the end of the day, right? So you can go in, if you think of a question that you wanted to ask or didn't get a chance to ask, you can submit through there. We'll keep it open during for the rest of the day. Same for everybody online who has submitted questions. We have those. What we'll try to do over the next week or so is look at all those questions, group them, come up with a frequently asked question doc, and have that posted in or around where the slide deck for this meeting is going to be also, so we can do our best to answer all those and take a little bit more time to think about what those answers are. But if you didn't ask anything here, you can still definitely get that in. And then there's the distributed generation and National Grid email address that you guys absolutely can use if you have specific questions. With that said, we will still have our job owners here for the next half an hour or so, right? If you've got specific questions about a job or other questions, I think the presenters are sticking around for a little bit too, and we can talk through that. But with that, I'll hand it off to you, Kevin.
Additionally, for everyone that's in the room, I know you all received paper surveys that were laid out on the seats when everyone came in. There is also an online link to the survey in the same Google form format. So if you're in a rush leaving, don't have time to fill it out, want to process it before you provide commentary, that survey link is also in the email that went out with the Google form specifically for questions, and that will also be open till the end of the day for you to provide feedback.
Yeah. Just one thing we didn't mention, which we like customers that help themselves. You can help us help you, and we do have a website that has a wealth of information on it, and I don't think we mentioned it. So, maybe I don't know if we have a link, but we can set. We'll just include the link in the PowerPoint deck that we send out, because there's a ton of process information, technical information, tariff, you name it, it's there.
So as the website was being referenced, we do have references from our presentation, including the interconnection process resources, the generic distribute generation website, the link to affected substations in terms of the cluster study and the SMART program. So you can reference that. This appendix 5 will be included in the final PowerPoint that is posted on our website, which is the first link on this page.
So a lot of information offered up today. Thank you for some great questions, really. A lot of super questions today, some good conversation. What I heard today, we've got a congested area in central and western Massachusetts. We've got an ISO New England that's more interested in our projects over 1 to 5 megawatts, certainly over 5 megawatts. If you're thinking of applying in that congested area, right, you're going to know there's going to be additional time to process that application. In that map, the black and the blue hashtag areas, those are other parts of our territory that aren't currently congested, right? So if you're thinking of where should I cite a project that has more likelihood of going through as it used to go through without ISO involvement, I would look at those areas first. Not that ISO won't, flag these projects if they're over a megawatt and 5 megawatts. Again, they're more aware of the overall congestion within the state, so they're looking at these DG projects more closely than they ever have. So you just want to anticipate that as you go through the interconnection process, that there's likely to be additional time to process these applications and potentially more cost than there had been previously. But as we've mentioned a couple of times, for the congested area where we've got the transmission cluster study going, we will set up a meeting next month and send out an invitation and again meet face-to-face with you folks in the not too distant future. So thanks again for coming. Please, leave the parking lot carefully and have a safe ride home. Thank you.
Thanks.